but it just might make it a little bit easier today if you got a calculator with you. Okay, so we're going to solve some equations. So the ultimate goal when you're solving an equation is to find the answer or the solution. So what do you guys think of if I say we're going to find the solution of an equation? Like, what does that mean? Just raise your hand and tell me, like, what do you think of when you think of what's the solution of an equation? Yeah. Something equals something. What else do we think about? Like a solution of an equation. What is the solution? The answer to, yeah, that's a good way. Okay, so I'm going to write, I know you guys are thinking right here. I'm going to write the value, meaning the number of the variable. And I'm going to write that makes the equation true. Okay, so most of the time I use x in a lot of my equations, but it could be a different letter, so I'm just going to say the value of the variable because that could represent a different variable than x. And that number plugged in, or that value plugged in, will make the equation true. Okay, so we're just going to solve some equations in this very first example. Some of them have a little different kind of steps you might run into while you're solving an equation. So the directions just say solve the equation. So anybody want to help me out with the first one? Just raise your hand. Like, how would you work on, you got 2 times the quantity x minus 3 plus 6 equals 70. What would you do? Okay. Okay, so what would you write? Perfect. Do a little distributive property, get rid of those parentheses. All right, what do you want to do next? Perfect. Perfect. Those negative 6, positive 6 cancel. We're going to divide by 2, and then we're done. X is 35. Exactly right. Anybody have any questions? Okay. What about my second equation? I got parentheses and variables on both sides. Go ahead. Okay, so what would you write? Perfect. Yeah, just be careful that that negative times a negative becomes a positive. Okay, now here, there's a bunch of different ways you could solve this. What do you want to do next? That's what I would do too. So plus 3x. That'll get all our variables on one side. So it cancels, negative 3 and positive 3 cancel. So we got 7x plus 36 is equal to 12. Okay, what do you want to do now? Minus 36. Sorry guys, my handwriting's too big. Okay. So then I get 7x, what is that? Negative 24. Now, at that moment, I'm probably secretly freaking out because I know 24 is not divisible by 7, so I'm thinking I made a mistake. But I didn't make a mistake. You can have a fraction as an answer. That's okay. So we're just going to divide by 7. We didn't do anything wrong. Now, it's up to you. I usually just leave the answer as a fraction as long as it's reduced. That's perfect. 7 doesn't divide or reduce into 24 at all, so I would just leave that right like it is. That's an exact answer. If you want to round it with a decimal to 2 decimal places, if it's kind of a nasty decimal, that would be good. I'm just going to leave it as a fraction, so that way I have an exact answer there, and I'm not rounding anything. We don't want to change that to a mixed number. Some people are very tempted to do that. We don't like mixed numbers in here, so don't do that. Just leave it. Improper fraction is perfect. Does anybody have any questions so far? Okay, let's push this up. Now, this next equation has been giving people problems all day today. Does anyone want to try part C? What do you think?
So first I distribute the negative 2.
Okay.
So it's x minus 6 plus 4x.
Okay.
And I combine the common terms. So it's 5x minus 6 equals 2x plus 9.
Okay.
And then I subtract the 2x, make it 3x minus 6 equals 9.
Okay.
And I add the 6 and then divide by 3.
Awesome. All right. So we should get, what, 3x is 15. We're going to divide by 3. The one thing, I just want to point this out real quick, the one thing that people were accidentally doing today, they were kind of trying to FOIL the x minus 2 and the 3x minus 2x in the very first part of that problem. You don't want to do that because you don't have parentheses around the x minus 2. So perfect what he did, just distribute the -2, cancel out those parentheses, and go from there. The x just gets combined as a like term. It's not a FOIL because there's not parentheses around it. Awesome. Okay, any questions on that one? Okay, now the next one everyone looks at and is immediately excited to tackle because it has 3 fractions in it, right? So I want to ask you a question, just if you're not into fractions, which a lot of times people, it's not their favorite thing, right? Let me ask you a question. Can you think of a number, and there's multiple answers to what I'm going to ask you right now. Can you think of a number that 4, 6, and 3, those are all my denominators. Can you think of a number all of those would go into? 24, perfect. Can we think of another number? What were you thinking of? Yeah. 12. Okay, 24 works. 12 works. We could do 36 would work. You can, the bigger the number, you're just going to have a little bit bigger numbers in the problem. I'm going to pick 12 because that's the smallest number all those will go into, just because I'm going to work with a little bit smaller numbers here. But if, as long as you pick a number that all 3 of those will divide into, this will work. So if you're not into doing the fraction, okay, I'm just going to multiply everybody by 12. You could use the 24, you could use 36, it's up to you. You'll just it will look a little different than mine as you go through it, but we'll have the same answer at the end. But if you can pick a number that all 3 of those denominators will go into, you can just cancel out the fractions. Now, the way that works, you got to remember, if you're going to multiply by a number to a fraction, right? Think of it as that number over 1. So don't multiply the denominator by 12. I'm just going to put it in the top. Okay, so I'm literally just going to sneak a 12 into the top of each of these fractions. So it'd be 12x over 4, 12x over 6, and then 12x over 3. Now, the one thing people will maybe make a mistake on this, they'll forget to multiply the other side of the equation, which was just a plain 9. If I multiply everybody there by 12, I got to do that to the 9 also. That'll give me 108. So that's really important. You don't forget all the parts of the equation. Now, if you picked a number they all divide into, you just watch this, it'll get rid of all these fractions. So 12 divided by 4, right? That's going to give me 3 with the x. 12 divided by 6, that's going to give me 2 with that x. And 12 divided by 3, that's going to give me 4 with that x. And now I don't even have a fraction at all. And I don't have to worry about that because I think sometimes that throws people off a little bit. So you can easily get rid of fractions. Just multiply every single term on both sides of your equation by something all those denominators will go into, and you'll be good. And then this becomes a lot simpler than what we just had. So just combine like terms here. So what do we got? We got 5 and 4, so we got 9x's is equal to 108. And then I'm, at that moment, probably grabbing my calculator to divide both sides there. Can anybody tell me what that should be? 12? Okay, so then my answer is 12. All right. Is anybody having a question? There's different ways to do that problem. I'm just giving you an option if you don't want to deal with the fraction. Easy way to clear a fraction is just multiply everything by something all the denominators will go into. Okay, now the rest of these problems we're going to kind of have to set up a little bit based on a situation. So each one of these we're going to solve an equation to figure out the answer, but whoa, I messed something up, sorry. I'm going to try and draw you a picture. I'm not the greatest artist in the world, but I will try here. So this says Adrian will use part of an outside wall of his house as one of the long sides of a rectangular garden. He wants the garden to be 3 times as long as it is wide, and he plans to use 68 feet of fencing around the garden to keep animals out. And we want to find these dimensions. Okay, now you don't have to draw a picture. I'm just going to sketch. I'm going to pretend like this is the back of his house. And we don't need fencing along that side because we could just use the house as part of the fence. So we really need fencing on only 3 sides. And he says the house is going to be one of the long sides. So I'm just going to kind of sketch a rectangle. I'm sure this is not drawn to scale, but I'm just going to sketch a rectangle next to where I kind of drew the house there. So the only other thing it tells us is we want it to be 3 times as long as it is wide. I maybe go about setting up an equation to figure this out here? Like, what would you do? Maybe put something together that would allow me to do that. What do you think?
You can just say like, the side lengths are like, say y is x. So you could say it's.
You can use whatever variable you want, yeah.
Yes, I can say it's x. And if the parameter is 68, then it's 3x plus 3x plus x is equal to 68.
You're almost perfect there. The only thing is, okay, let's call the width, you could use, we'll just call the width, I'll say the width is x. Okay, so I'm going to make the two shorter sides x. Now, for the length, it's supposed to be 3 times the width, so this would just be 3x. I just don't need the 3x on that other side against the house, because the house, we wouldn't want to have a fence right up against the house. We wouldn't need it. So you only need 3x on one side, otherwise perfect. And then all you got to do, add those guys up, and we're going to set it equal to 68. So you got 2 x's for both of the widths, and then 1 length, because we're going to use the house as the other length. So we got 5x and we got 68 feet of fencing to work with. Now, this is not a nice integer, but this is a decent decimal. So I'm going to divide both sides by 5 real quick. X is the width here. This is going to be 13.6. And it said, what is it? This is in feet. So the width of this garden is going to be about 13.6 feet. Let me go, I'm going to come over here just real quick. So my length, the only thing we knew about that was it was 3 times the width, which I called x. How would you figure out the length then of the garden? Exactly, okay? We're plugging this in like a Glade air freshener, okay? Plug it in, plug it in. So put in that 13.6 for x. This ends up being some number that I don't know. You got 40, okay. 40.8 there. Okay. So that's my length. This 13.6, this is going to be the width. Okay. Anybody have a question? Okay, I'm going to see if I can do this one here real quick before we go to lunch. Okay. Now, there are 2 problems like this on the homework assignment. One is actually going to be more similar to kind of the setup we just did, and then one is going to be similar to this question that I have in part B here. So a little geometry throwback, see if you remember this. Before I get to the geometry part, I'm going to just set something up. It says the difference between an angle and its supplement is 62. What do you guys think of if I say the word difference? Subtraction. Okay, so this just means I've got 2 different angles. I'm just going to use 2 different variables. You can use whatever you want. I'm going to use x and y. So the difference between these 2 angles, so I'm just going to say x minus y, is 62. Okay, now my problem here is I got 2 different variables in only one equation. So if I want to solve this, I got to have another equation with the same 2 variables. The key to that is going to be that it says these angles are going to be supplementary to each other. Do you guys remember what that means from geometry? If I have 2 supplementary angles, they add up to 180. Okay, so here's the only thing I'm going to do. I'm just going to say the 2 angles, if I add them together, so I'm just going to say x plus y, I know if they're supplementary, they have to add up to 180. Sorry guys, shaking all over the place. Okay, now, I got 2 equations with the same 2 variables, so we can solve this. And this is a system of equations. Anybody, there's different ways you could do this. Anybody have an idea what they might do to solve that system? What are you going to do? Okay, which one do you want to use? Doesn't matter. Okay, maybe we get like x by itself, right? So all we would have to do there, I'm just going to add y to both sides. So I'd have x equals 62 plus y. Yes, you can. Okay, that's what I would do if I was using substitution. So if you guys want to do that, you can. And you would just plug this in for x in the other equation. So if you want me to work that out real quick, and then I'll show you another way, which was what she was just saying. If I sub this in, I would sub it in right here. So I'd have 62 plus y plus another y equals 180, and we could go from there. Okay, now, if you love substitution, and some people do, and I do in certain situations, That would be perfect. If you notice this though, this one might be really quick and easy to do elimination with if you want to use that method as an option as well. So either one, whatever one you like better. But you do have opposites on the y's right then and there. You could just add the bottom line to the top line and use elimination to get rid of that variable, or you can use substitution. You're going to get the same answer. If I use elimination, you just add the bottom line to the top line, the y's cancel, you get 2x is equal to 242. Then you're just going to divide by 2. So one of the angles is going to be 121 degrees, and if it's supplementary, I would just real quick do 180 minus 121, and then your other angle there is going to be 59. So either method would work. You'll see if you went through and did the substitution, you get the same thing, but elimination might be a little bit quicker there. It's just kind of depending on what you like better. All right, I'm going to stop there for a moment because we're going to go to lunch. So you guys should have a lot of time to work on homework today. Okay, now this is a little bit geometry related, kind of like the last question was right before lunch that we were looking at. So this is not bad to solve, but it's kind of weird to think about how to set it up. So this is the sides of a quadrilateral are in proportion. So there's 4 quadrilateral, I can't speak, is 4 sides. So that's why you have 4 parts to that proportion. So it's 1 to 2 to 4 to 5, okay? And then it says the perimeter is going to be 138 centimeters. Does anybody know how you can use that proportion to help you set up an equation to figure out the lengths of the sides? And I have a little quadrilateral drawn there. It's maybe kind of close to scale, not perfect. But any idea how to set that up if you've got the sides in proportion 1 to 2 to 4 to 5? You don't have to use a fraction. It's probably been a little bit really thinking.
So could you put like x on one side and then 2x and then 4x?
Exactly. Okay, if you get something like this big, long, drawn-out proportion with sides or angles or something like that, you literally just attach an x, the same variable, to each one. So, like for the 1, I would just call I'm just going to label the picture. You don't have to. You could just write it out if you want. But, so you have 1x, and then one of the sides is 2, one of the sides is 4. You just attach the same variable to each one of those. And x is going to represent there what that proportion is going to be. So then all you have to do, you're just going to add these guys up and set it equal to the perimeter, which is 138. Okay, so I'm just combining like terms, right? So I have 1x, 2 more, so that'd be 3, 4 more, that'd be 7, 5 more, that'd be 12. So if I add all those guys up, I'd get 12x is equal to 138. And if you divide 138 by 12, I think, tell me if I'm wrong, but I think it's 11 and a half. Okay, now all you got to do to tell me the side lengths is literally, like I said on the front, plug it in like a Glade air freshener. Okay, so we got, this would be 11.5. Take 11.5 times 2, so it'd be 23. 11.5 times 4 would be 46. And 11.5 times 5, pretty sure is 57 and a half. And so that's all you would need to do. Just if you get it in proportion like that, it could be sides, it could be angles, just attach the same variable to each number in that proportion, and then you just add them up. Okay, and then the last one here before we get into consecutive integers is very similar to a question that was on that review you guys looked at yesterday. So the reason I keep putting a question like this on here is because they always have something like this on an SAT or ACT. So I think these are good questions for review because I feel like they come up a lot and they relate to other class. You could use this for any class in terms of finding an average. So this is Matt's taken 4 science tests and it gives you his scores. So 72, 91, 67, 83. And then it says what score is he going to need on his next test. So he's going to take one more test to make the average an 80. So average, I think yesterday I had the word mean, but those two words are interchangeable. Any idea how I could set up an equation to help me figure out what he needs?
So I'm looking at all of this plus x. So all of that divided by 5.
Perfect. Yep. Okay, perfect. So we're going to take 5 tests. So whenever you find an average, you're going to divide the number of items, which in this case is going to be the 5 tests, by however many there are. So if there's 5, we're going to put the 5 on the bottom. we just got to add all those up. We don't know what we get on the fifth test, so you could use any letter you want. We use X there in mine if you're looking at my paper. Now, easiest thing I can tell you to do. Let's not mess around with the fraction. I'm just going to multiply both sides by 5 real quick, get rid of that. And all it's going to do on that left side is get rid of the fraction. It's just going to cancel the 5 out. Now, 80 times 5, that's going to give you 400. And then what I'm going to do, I'm just going to add these guys up. So add these tests, so 72, 91, 67, 83. If you add that up, you should get 313 plus that fifth test. Now I want this to equal 400. That's what I got when I multiplied 80 times 5. Then literally all you have to do, just subtract the 313, and that'll tell you the test score you need, which is just going to be an 87. So, does anybody have any questions? Okay, now the rest of this goes with the concept of consecutive integers, but before we get into consecutive integers, I thought perhaps I should ask you if you just know what it means for a plain integer. So do you guys know, like the term integer is talking about types of numbers. Do you guys remember what an integer is, or what does that mean to you? Yeah.
Is that any positive or negative number, or just
It can be positive or negative. What else does it have to have or not have? Has to be whole. Can't be a decimal, no fraction. So it's literally just, it. Like I'm gonna just put a dot, dot, dot. Like we could do negative. It's just, they're just plain. It can be 0. It's plain numbers, no decimals, no fractions. Whole numbers, technically that is a category that you can classify numbers into. Whole numbers mean 0 and then 1, 2, 3, 4, 5. When you have integers, that adds negative numbers into the whole numbers. And so it can be positive or negative, but no decimals, no fractions. That's what an integer is. Okay, now, does anybody know what I mean by the term consecutive integers, or could you give me an example? Perfect. Like 12, 13, 14. Those would be a perfect example. It's just like numbers right in a row. Okay, now, just for the purposes, because we're going to set up some equations here, a lot of times people will kind of default to doing trial and error with these problems, but I promise you, you can use a little algebra to make them a whole lot easier. So I'm just, where it says consecutive integers, just put a little example there. Okay, I'm going to put like the most basic couple positive consecutive integers. So I'm literally just going to write, I'm going to write 1, 2, 3, 4. Okay, we could keep going. I could go like 5, 6, 7, 8, keep going. I'm just going to do 4 consecutive integers here. And I'm going to show you how to represent this algebraically. So you can pick your favorite letter that you want. I am just going to use X because that is the default for my brain apparently. So if I let algebraically, I'm just going to think about this. And so I do this on a lot of these problems. I'll just write down an example of consecutive integers for myself to kind of think it through. If I let X represent just 1, could you tell me an expression I could use to represent 2, not using any other variables? Okay. X plus 1. All right, so that would be X and X plus 1. That would be 2 consecutive integers. How would you represent the 3? X plus, you guys get the pattern here, X plus 2. 4 would be X plus 3. And we could, we could keep going. If they said we had 10 consecutive integers, I could keep writing out expressions like that. And that can make these problems easier to solve. Okay, now, those just plain consecutive integers. Now, underneath, you kind of run into some problems sometime where they'll say specifically consecutive odd integers or consecutive even integers. Could anybody give me like a little example, 3 consecutive odd integers? Perfect. Okay, so 1, 3, 5. Right, those are all odd numbers. Now, let's think about how we would represent this algebraically. And sometimes this is weird for people. So I'm just going to tell you that up front. Okay, so let's say I'm doing odd integers, and let's say I just call 1 x. How would you write an expression for the number 3?
X plus 2.
X plus 2. How would you write 5?
X plus 4.
Exactly. And the reason I say this will throw people off is because they're thinking they're talking about odd integers, and then they see even numbers in that algebraic pattern there, but that is actually correct. Okay, what if we did 3 even integers algebraically? So like 2, 4, 6. And let's say I represented 2 with an X. How would you represent 4? X, and this also throws people off because they're like, what the heck? That's exactly the same as this. 6 would be X plus 4, but this is correct. Algebraically, you would represent the odd and even consecutive integers. It's exactly the same. The question as they set it up is just going to depend on whether they're odd or even and if that is correct. So those are actually having the same setup, odd or even. But basically you're doing X, X plus 2, X plus 4. You're skipping one in between. If I did another one, it'd be X plus 6, X plus 8, and that pattern would continue. So we're going to try a couple of these together, and then I'm going to have you guys try one on your own. All right, so find 4 consecutive integers such that the sum, what do you guys think of when I say sum? Addition, right? Okay, such that the sum of the integers is 186. Okay, so again, you don't have to do this or anything. I'm just going to write 1, 2, 3, 4. You could just look up above, and I'm going to represent X, X plus 1. This just says straight up consecutive integers. It does not say odd or even or anything like that. So algebraically, I could just use those 4 expressions. If I'm doing the sum, literally all we're going to do, we're just going to add these expressions together. I'm just going to do it vertically real quick, just right here, right? I've got 4 x's all stacked on top of each other, so I'm adding them up. 1 and 2 would give you 3. The other 3, I'm just adding these, combining these numbers. That's going to give you 6. And then it says the sum is 186. Then we're just going to do 2 steps real quick. We're going to subtract 6. So I'm going to get 4x is equal to 180. And then we're going to go ahead and divide by 4. And I think that's 45. So once you solve that equation, that's going to give you the very first of the 4 consecutive integers. So I just come back over here, usually where I wrote this out. So my first number is 45. Add 1 to that, so it'd be 46. Add 2, you get 47. Add 3, you get 48. And those would be 4 consecutive integers that if I add them up, it's going to total 186. Anybody have a question? It's so much faster to do that algebra than trying to sit there and do trial and error for 10 minutes. Okay, I promise you, it's way easier to do the algebra. Okay, if I do 3 consecutive odd or even, it would be the same setup. This situation is odd, so I'm going to think about my 1, 3, 5. And I'm going to do a sum again, so I'm just going to add these up. So the first integer, we could do x. Since it's odd, we're going to skip 1 in between. So the next expression would be x plus 2. You got 3 here, so then the next one would be x plus 4. I would literally just add those up. You got 3 x's stacked on top of each other, so 3x. 2 and 4 is 6. And you set that equal to the sum, which is 195. And then from there, you're good. Just subtract 6. So we're going to get 3x is equal to 189. And then I'm going to divide that. So that should be 63. Now that's your first number. And then I just go back and look at the expression. So 63, add 2, that's 65. Add 4, that's 67. Those are all odd integers. They are consecutive. And if I'm going through one of these problems, if you get like a 0.5 or a decimal or something, then something might be a little bit off with your setup. So just keep that in mind. But those were automatically odd integers after I solved that equation. Okay, you guys see if you can solve this last one. You probably want a calculator for it because it's got a pretty big number for the sum in this. It has 4 girls that are sisters, and it says they were born in consecutive years. The sum of all the years they've been born in added together is 7,982. This is just consecutive. It's not odd or even, so you're not going to skip anything in between. It'll just be like 1, 2, 3, 4. See if you can find what years these girls were born. Maybe write out a little equation to solve for that, and then see if we can figure it out. And feel free to use the calculator. And if anybody's in need of one, you're welcome to borrow one of mine back in the day while you're in here. Just put it back in free good. And then if you guys get done with this, I'm just going to give you the rest of the time to work on the homework assignment today. So if you're feeling good about it, that's what we're working on. Anybody feeling good about what years they got for these girls being born? What'd you get, Liv?
94, 95, 96.
Perfect. It should be 94, 95, 96, and 97. Does anybody not get that? Want me to go through it? Okay, perfect. I'm going to give you guys the rest of the time